Anybody from the Informatics students are here? And do you hear me? Alright, let's check your Neptune message. It's there. Or I hope I sent it. Let me double check. Do you see it? You can also download the presentation. Alright. So perhaps you remember calculating, for example, the rotation kinetic energy for a cylinder rotated along the longest axis, or calculating any kind of kinetic energy for rotating object is not that easy, only using the kinetic energy equal 1 over 2 mv square formula, because the points of the body close to the axis and far from the axis has different v. Oh, wait a bit, I have to move a bit. Yes, it's better. If you look at this object, the V depends on the R even for a constant omega, constant angular velocity. What can we do? One thing we can do this sum, so calculate the kinetic energy of all of the point of the body. So this is a system has several point can be, for example, a small piece of box of the body. If we can calculate it, uh, you can have this formula means the rotation kinetic energy also starts with the 1 over 2 and ends with something which is related to the motion of the body. So here this v square, v is something about how the body moves, and the mass, it's about the body. And v is how it moves. This formula is very similar. 1 over 2 and something about the body and something about the body how it moves. And this is the so-called moment of inertia. You can calculate the moment of inertia, for example, by integrating the body. I mean, this is a volume integration, a 3D integration. It's not easy, but can be solved. Or we can memorize some formula. For example, cylinder is 1 over 2 mr square, or solid sphere, thin spherical shell, or some rectangular plate rotating along one of the axes. It's not that hard. Alright, so what if I want to calculate the rotational kinetic energy of a body? Let's do this example. The radius is 0.2, the mass is 10, omega is 10, 1 over s, L is 1 meter. The formula is 1 over 2 moment of inertia times omega square. And for this moment of inertia for cylinder is 1 over mr square. If we put everything in one formula, replace the capital I here with 1 over mr square, we can calculate it. And just look at it. If you rotate this axis, if you rotate the cylinder around this axis, the energy of the rotation is independent from the L, from the length of the cylinder. Of course, if you rotate by using, for example, horizontal axis, the L will take part in the formula, but in some special cases like this one, some parameter of the body even doesn't matter. Let's calculate this one. So for example, the same radius, same mass, same velocity, angular velocity. The cylinder, if it's a solid, I mean a full ball, or a full, yes, sphere, it's 2 over 5 mr square. If it's a ball-like structure, which has the mass only at the thin sphere, it's 2 over 3 mr square. If we want to calculate the rotational kinetic energy, we can solve it, and that's all. So today, at least, you have to calculate the rotational kinetic energy of a body. It can be a cylinder, solid sphere, thin spherical sphere with these parameters. So I'm waiting for the result in the Discord. I've sent the link of this PDF so you can go back for formulas. But here you can also find. So calculate the rotational kinetic energy of these bodies with these parameters 0.3 meter, 5 kilogram, 15 1 over s. This is the full ball, and this is an empty ball. Still waiting for the results. So 1 over 2, 1 over 2, 5 times 0.3 square times 15 square, and here we have to change 1 over 2 to 2 over 5, and 1 over 2, 2 over 3, and the rest is the same. Please calculate the kinetic energy of these rotating objects. Guys, girls, somebody should calculate it. This is a seminar. All right. Let's say this is omega equal 15 1 over s. Calculate the energy of this rotating object, then increase the omega to 20 1 over s. I want to see not only the energy but also the energy differences. I can't see the 1 in this 1 over s. Just a minute. Here we have an extra 1. Alright, oh, it's there, great. So, that will be your homework. Ah, thanks. Somebody calculated. Alright, so please calculate the energy, the rotation kinetic energy of this body, then increase the omega to 21 over s and also calculate the new energy and the energy transfer, because next time we will work with the torque, and torque is like the force. This is that will do some work on the rotating body and that will increase the energy. Alright, so calculate the energy and the energy transfer and let me send it, or just let's talk about it next seminar. Right now I also have to move, and since you are more or less inactive, I think do not waste too much time. So do it as a homework. Next time we'll talk about it. Bye.